Hello, everyone. Good afternoon. I hope everyone is awake. It's a second session after lunch, so bear with me for next 10-15 minutes. Hi, my name is Balasaheb Salunke. I work on Kubernetes and container security. I started my career in web application scanner and DAS tool, and passionate about supply chain security, DevSecOps automation, and policy enforcement. Apart from work, I like enjoying swimming and reading books. So that's a short intro about me. Let me dive into today's talk. So welcome and thank you for joining Bridging Silos, the real-time DevOps telemetry for container defense. So being from security, more on the security side, I was trying to explore how security and observability can work together and get basically securize the containerized workload. So in this session, we will explore how to unite security signals and the traditional observability data, such as trace, logs, and metrics, to defend containerized application. The goal is to break down the silos between ops and security, hence bridging the silo, by using real-time telemetry that benefits both the teams. I will also try to demonstrate how we can get the alerts from different security systems and inject into the observability platform. And basically, that will help for a faster remediation and detection. So let's break it down what we are going to see today. So the silo problem, how ops and security team are drifted apart, why there is an even gap exists. We'll dive into one of the threat called cryptojacking. Then we will try to bridge this gap by building a unified pipeline, and then benefits of this unified pipeline. Let's first acknowledge there is a gap between the ops and security. And there are reasons to have that gap, right? Ops primarily focusing on metrics, dashboards, right? They want greener dashboard and faster velocity. On the other side, security more concerned about compliance, risk, triage. And it's obvious to have different monitoring tools to be getting used by these two different teams. And hence, those two data points are always looked from a different lens. For an example, let's take an example of CPU spike on the dashboard, right? It could be a legit spike, or it could be a malicious attack. But unless observability team knows there is some security events also happening, they will not be able to pinpoint whether it's a legitimate behavior or a malicious attack. Meanwhile, security team, they have something called runtime events without knowing the application context. They could get multiple security alerts, but they don't know its impact on the application performance at that moment. So that basically impacts on the slow detection of an issue, whether it's a legit issue or whether it's a malicious attack. Let's try to understand why the gap exists, right? If you look at the way ops and security team works, they work with a different character and KPIs. Ops primarily looking at uptime, SLA, as I said, right, release velocity. Security more on risk, compliance, and triage. So traditionally, they are looking to solve a different problem. If you look at the data volume for both of these teams, it's completely different. On the ops side, on observability side, it's a big volume data for midterm analysis, and they look at the data from the bird's eye view, right? They doesn't need to go in each and every event unless there is an issue. However, security is more critical because they want to find it out, any possible attack happening, and any compliance thing that could cause an issue to an organization. That basically dictates how backends are also designed for observability and security. And of course, I mean, there is a difference in the skills and the tool diverge. Ops folks more expertise on APM, troubleshooting, and whatnot, and security teams more on the threat detections, advisory, and finding the attack patterns. They might look at the same event from a different perspective. So I would say it's not about incompetence, it's more about perspective, how they look at the data. To ground this into concrete example, let's talk about an attack which is basically quietly consuming and basically draining the cloud budgets for organization. Cryptojacking. Cryptojacking is a way attacker run crypto miners on your container, which is unauthorized, right? And at a first glance, you won't see this getting impacted because it doesn't try to theft your data, right? Or it doesn't trouble your services running, so it doesn't come on the ops dashboard. Everything looks green, at least from the service perspective. But internally, it is getting used to make money for someone else, whereas organizations are paying hefty cloud bills. So if we look at the stats, only in around 2023, around 1 billion cryptojacking attempts had been done, which is 700 raised from previous year. And the real world cost is huge, right? Organizations are spending huge cloud bills because of crypto miners running in their environment. So some of these examples where small organization had to pay more than 500K, 300K on their cloud bills for the workload that they never used. I think we had to I'm running out of time. I will try to go over the architecture of what I was trying to present is basically a unified pipeline where we ingest the data from observability pipeline, the existing pipeline, and the security systems, which generally triggers the alerts, right? So this, and yeah, so I was planning to demo around cryptojacking attack kind of thing on OpenTelemetry astronomy shop. And for that thing, I did modified small changes in the astronomy shop. Basically, this is POC code where I have introduced the remote code execution just to demonstrate, right, how crypto miners can be injected and launched for crypto mining. Maybe I can show one screenshot, maybe that will give some idea about how observability data and security alerts can put together. Here you see the CPU spike and the alert, drop and new binary executed. I think I'm running out of time, so I have to stop. Thank you so much.